Here we go, round 2, adding vectors mathematically. I guess we're always adding them mathematically, but adding vectors, mathematical method instead of graphical method. All right, so this one is actually not too bad. And what's nice about this is we will get the same answers, whereas the graphical method, we were off by a couple degrees and so on. And it was more of an estimate. And it's important that you learn the graphical method because this should make sense then. So if you have any vector, right, that looks like this, let's say that's our vector. We can say it's made up of two vectors that when added together, head to tail, make that vector, right? So I can work backwards and say, well, that could be this vector plus that vector. When I add these two together, I get the black vector as the answer. So I could say those two added together, head to tail, equal the black, right? I could redraw that vector again and say, or let's get rid of these and say it can also be two vectors like this. I could say, well, that could be this vector and this vector, right? So any two vectors, I could make it three vectors. I can say, let's let that one be the result of 3, 4 vectors, doesn't matter. So again, I can say, oh, that can be the result of going that way, going straight across, and then I can add a third one here, right? So if I had those 3 colored vectors, the red, the blue, and the green, and I add them head to tail, I would end up with the black vector, right? So what we call these colored vectors would be called component vectors, right? And this is the resultant vector. Well, I can restrict my rule to say you must add together vectors that only go horizontally and vertically. Otherwise, I have an infinite number of things that I could add together to equal this vector. So if only allowed to go horizontal and vertical, then an idea would be to go straight across like that and straight up. By restricting myself to be horizontal and vertical, I create a right triangle. And in that right triangle, I would say that these two vectors add up to give me the original vector. So mathematically, in the graphical way, we would say this equals this vector to the right plus this vector. So if we go back to the graphical method, if I would use the head to tail method and add these two vectors, I would get the original vector. Just like mathematically, if I'd say I have the number 10, I can let that equal 7 plus 3. I can also say 10 is equal to 6 plus 4, right? 5 plus 5. Just like I was saying at the beginning, and if I were allowed decimals or many numbers, if I say, okay, it can be 2 plus 2 plus 2 plus 4, right? So mathematically, we can substitute these combinations to get the original. What I was saying earlier, vector math, there's a combination of vectors that can be added head to tail to get the original. But if I put a set of rules on it that says all your numbers must be even and you can only use 2 of them, then the only choice of these would be this. I'm not allowed to use decimals and so on. So we're doing the same thing up here. If this is my resultant vector, when I add two vectors together that are restricted to be horizontal and vertical, those two give me that original vector. So in a mathematical equation, I could use these two values instead of 10, right? So in a problem, I can use these two values instead of this one. So that's the goal. So the goal is we want to look at vectors as having these X and Y components, right? So to do that, we want to go back to this idea of a right triangle. So just to review a little bit from your math class, if you have a nice right triangle, this is called the hypotenuse. If this is the angle theta that you know, this is the adjacent side, and this is the opposite side. So using the right triangle, Chief SOHCAHTOA, right? Very important in trig. What it tells us is that the sine of the angle theta is equal to the opposite divided by hypotenuse. The cosine of an angle theta is equal to adjacent divided by hypotenuse, and the tangent of the angle theta is equal to opposite divided by adjacent. So that's from math, right? That's a tool that you used in math class. We're going to apply it to this triangle that we just made with our vector quantities. So with I have a vector, right, that I might say, here is my vector that is worth 100 newtons at an angle of 30 degrees. I can figure out its x component and its y component using the trig, right? So using the trig, this vector, this would be my hypotenuse, right? That's my x component, that's my y. And as far as x, that's the same as the adjacent side. And then this is the same as the opposite side, as we had previously. So if I'm interested in the x component, right? So I can break this up into my x component and my y information. In the x, it goes with the cosine function. So here I would say the cosine, be consistent in our colors. I would say the cosine of 30 degrees is equal to my x component divided by 100 newtons. So 100 newtons times the cosine of 30 degrees is equal to my x. Similar in the y, we would say that the sine of the angle of 30 degrees is equal to the y component divided by 100 newtons. So 100 newtons sine 30 degrees is equal to my y component. Plugging that in our calculators, we can get our answers for that. So if we plug that in our calculators, we get this to be 51.96 newtons is my x component, and 50 is my y component. So 51.96 at 0 degrees plus 50 at 90 degrees come together to equal 100 newtons at 30 degrees, right? So as vector notation, that's what we could write. 100 newtons at 30 degrees is equal to 51.96 newtons at 0 degrees, that's the x, plus 50 newtons at 90 degrees. That's our y component. So going back to the vector notation that we used, this statement is true. These two added together equal that vector. So if we go to our worksheet on our mathematical methods, right, we have this. So to complete this, list the vector. So the first thing you can do here is say what your vector is. So if I'm going to do this one first, I would say, okay, let's look at the 60 newtons at 40 degrees. And off to the side, I'm going to draw that just to let me know which direction the x and y components are going. What is the direction of my x and y components? So we would say the cosine, so if this is 40 degrees, the 60 is our hypotenuse. The cosine of 40 degrees is equal to my x component divided by 60. So 60 cosine 40 degrees is equal to x, and that comes out to be 45.96 is my x component. In the y direction, the sine of 40 degrees is equal to the y component divided by 60. So 60 times the sine of 40 degrees is equal to my y, and that's 38.57 newtons equals my y component. This is also unit of newtons. And then I want to do the same thing for the 30-degree one, 30 newtons. So 30 newtons at 20 degrees might look like that. It should actually be half the length. So if I really wanted to do it correct, I would make that only half as long, right? So this should be very short, little one, but only at 20 degrees and 30 newtons. So we could continue here to say the cosine of 20 degrees is equal to that x component divided by 30 newtons. So 30 newtons times the cosine of 20 degrees is equal to that x component. The y component of that is sine of 20 degrees is my y component divided by 30 newtons. So 30 newtons times the sine of 20 degrees is equal to y. So what I have right now are an x and a y component of each of the two vectors that I'm trying to add together. So here's an x, right? I'll let you plug that in your calculator to get the answers to those. And then I have a y component and a y component. So what do we do with those if I have those two values? Okay, if you plug those in your calculators, this one comes out to be 28. Oops, go back to the black. So this one comes out to be 28.1 newtons is my x component. And over here we have a 10.26 is my y component, newtons. So there's not a lot of space here to solve these. If I recommend you do that on another piece of paper. But let's go back to our whiteboard and say, okay, well, where are we? You have these two components, right? When you break up each vector. So now what I actually have, if I want to add two vectors together, right? So here's what we're going to do conceptually. We have this vector plus this vector, right? Something at 40 degrees and something at 20 degrees. We found their x components for each of them, and we found their y components. Okay. What we have seen in the past, what makes it nice, is that anything in the same direction just adds, and if they're just completely in line but opposite direction, they subtract. So what I can do here, these two vectors added together would be the same as if I just add all their components the same way, right? So that's the same as me adding this component plus another x component, right? Plus the two y components. So that's what I can do. So basically I can add my two x's to get one big X, and I can add my two y's to get their total, what I get them when I add them head to head, right? I'd end up with something like that. These tail to head, right? Your total would be something that looks like that. So conceptually, that's what we're going to do. We want to add our x's and add our y's to get a total x and total y. So I'm going to skip over to here. When we were doing this worksheet, you had 60 newtons at 40 degrees plus 30 newtons at 20 degrees, right? 30 newtons at 20 degrees. I think that was our problem. Go back to this. 60 at 40, 30 at 20. Okay, so what we want to do here is say when I add those together, I want to add up the x's and make a whole column to say what was my x component and what's my total y component. So when I add these together, we had 45.96, okay? And we had a 28.10. In the y direction, we had 38.57. And in the y, we had a 10.26. So those are the x and y components of each one of those. So just running out of room on this page, okay, that's basically what we want to do. We're going to draw the line here, and we're going to add our x components, and we're going to add our y components to get a total x and a total y. So in this case, my total x, right, do that in my head, 14,674.06 newtons, and my total y, because they're both going up, these are both going to the right, I'm just going to add those. 48.83. So now I have a total x and a total y. And we'll work next week on Monday on what we do with these two totals. So what I want you to do for homework is to find the x and y components, find the x and y components for numbers 2 and 3, add them up to get the total x and the total y. Just a word of precaution here, when you have 110 degrees or 170, draw those off to the side. So let's use the 170. It might look like this, right? Well, its x component is going to the left and a y component. This is 170 degrees, but in here is going to be 10 degrees. So it still works. You can use the cosine of 10 degrees to get the x component and the sine of 10 degrees. But you have to recognize that this is pointing to the left. So you really want to make that a negative number, which you would get if you use the cosine of the full 170. We'll talk more about that on Monday, but just something to think about. If something's pointing to the left because it's 170 degrees, the actual triangle that gets made is this one, and the angle that's in that triangle is 10 degrees. But what you will find is the cosine of 10 degrees is equal to the negative of the cosine of 170 degrees. They're the same value, but one is positive and one is negative. So you have to recognize, what does that negative mean? And in this case, it would mean that it points to the left. All right, have a wonderful weekend, and I'll see you on Monday.